Hello everyone, welcome to this new series of 100 most important topics for your prelims 2026 by Drishti IAS. And today in this video we are going to talk about some major important topics related with your science and technology. So let's start the video. So in this video we are going to talk about the first thing, very important one, satellite navigation system, where we are talking about NavIC, Indian Regional Navigation System, and we compare it with the GPS, means global positioning system, and the role of atomic clock and signal bands. The second one is your observational astronomy, where we are going to talk about James Webb Telescope and Hubble Telescope, XPoSat, X-ray polarimeter, and black hole studies. And also we are going to talk about the celestial objects, means pulsar, magnetars, quasars, nebula, and the life of stars. So this is the thing that we are going to talk about in this video. So in a very first part, what is the satellite navigation system? You know that sometime there is a thing like infrastructure which is present on the land that can be destroyed with the disaster. And naturally sometime it can be totally destroyed, so the people cannot be connect easily and we cannot get enough information. So we use it for as a satellite navigation system, because satellite is placed far away from the surface of Earth, so it cannot have any impact of natural disaster on Earth. So this is your navigation satellite system. So it uses the satellite, so we use the satellite for it. Also there is an atomic clock, very important one, an atomic clock to provide the position, also navigation and timing. This is known as your PNT services. Also, receiver calculate the position by measuring signal and travel time from the satellite. So this is your navigation satellite system. And when we see, there is a two major thing, one which we have, Indian navigation system, that is called NavIC, and one is American global GPS system. So first we compare both of them and you see the major point between them. The first thing is NavIC. The full form is Navigation with Indian Constellation. It is developed by ISRO and it can cover regional area, because this one is known as Regional Navigation Satellite System. So this one cover India and 1500 kilometer around the India. Number of satellite is totally 7. This one is known as IRNSS 1 series satellites. IRNSS means Indian Regional Navigation Satellites, and they are placed in the orbit, which is placed in GEO and GSO. Civil services, yes, there is a civil services present also, and we made it for military and restricted services also. There is also it is present, and the accuracy is 50 to 20 meter for civil, and independence means indigenous technology based. But when we talk about the GPS is very famous nowadays, but every country can now make their own GPS also. So this is known as your global positioning system, developed by the US Department of Defense. This is a basically defense property. Coverage is global, but the number of total satellite is 31. 31 operational satellite is present, and this orbits present in MEO. We already talked about it. And there is also a civil service, and also there is a military restriction services is present. The accuracy for it is 5 meter, and it is dependence for the foreign system. So this is the major difference between your NavIC and GPS. NavIC is your Indian constellation based. We also have a good accuracy. The 5 meter accuracy is for the defense and military purpose, and 20 meter accuracy for the normal civil applications. When we more talk about the orbital configuration about NavIC and GPS, this is very important for your prelims. So NavIC is basically have 3 satellite which is fixed over India, and if they are fixed over India, we have to place it in GEO, and there is also second thing that is called 4 satellite in GSO. So GSO are little bit tilted with the 0-degree angle, but they are always focus on Earth and India. Advantage kya hai? So continuous visibility of India, so that can make the continuous visibility on India. And when we talk about the GPS, so GPS satellite move continuously because they can cover the entire Earth, and they receive the usually track 4 to 8 satellites simultaneously. So GPS can provide the signal and position by 4 to 8 satellite in every place. They can rotate like this, but Indian NavIC system have 3 fixed satellite over the India, and 4 can move some angle with it. So this is the basic configuration of orbital system. And when we talk about the role of atomic clock, which is very important one. So this is very important one. Why the atomic clock is needed? So it is present in satellite, and 1 nanosecond error are there, so that can be make a 30 centimeter possible change on Earth. So this is very precisely needed. So navigation depend on precise time measurement that can be done by your atomic clock. And in satellite we are using this, but NavIC have rubidium atomic clock, but GPS have rubidium and cesium atomic clocks. So this one is also very important, that Indian NavIC system have rubidium, but GPS have rubidium and cesium atomic clocks. When we talk about the function, that how it can work, so satellite can send the signal with the exact timestamp and the signals received by Earth, and this one receiver calculate the distance and time with speed of light. So this is the system for positioning by atomic clock, very important one. And also for the communication of space with these systems, we are using different type of signal bands. And this one is very important point. When we talk about the NavIC signal band, so there is a L5 band we are using normally. S band, that is most important one, because S band is unique feature for NavIC, because use of S band which is not used by GPS. So GPS cannot use the S band and we use it, so we have a precise signal for it. When we talk about the GPS signal bands, there is L1, L2 and also L5. So L5 is used by both of them, and L5 is for safety of life application, but L2 is used for encrypted and civil, and L1 is for civilian. This is something related with your GPS. And a unique feature uses S band, which is not used by GPS. This one is a very important point. And let's move forward and talk about the type of services. So when we talk about NavIC, NavIC provide you standard positioning service known as SPS, and it is a civilian purpose, means the normal person can utilize the NavICs by this kind of the signal, but there is a defense signal also which is restricted for normal person, and this is called as RS, restricted services, and this can be very strategic, military purpose, defensely used. But when we talk about GPS, there is a standard positioning system just like we have SPS, and also precise positioning system that is called PPS. So normal civilian signal have a same name, but when we talk about the restricted one, so this is called PPS for GPS and RS for your NavIC. This is again a big difference. When we move forward and talk about the strategic importance of NavIC, you know that the base for development of NavIC is your Kargil war, because during Kargil war, India wants to get the signal of GPS for precisely hitting on the borderline and enemy, but America denied to give these services to us by saying that it is our defense property. So that day India decided we want to make its own GPS, and this is NavIC. So this can reduce the dependency on the foreign system. Now we cannot depend on other thing, and useful during the war and emergency because we have our precise own signals. When we talk about the application part, so we use it maximally. This one is more important because this is our prime area where we focusing disaster management, fishery and transport, that for the water navy, and there is a mobile navigation for normal civilian purpose. But we also precisely control the agriculture system and also timing and telecom with power grids. These all the things which is related with your NavIC. Let's move on and talk about some space astronomical bodies, and the first one is known as your pulsar. So pulsar, look at that, a very magnetized material, and the pulsar is very interesting. This one is present in space between the galaxies. So this is highly magnetized, rapidly rotating neutron stars. Rapidly rotating neutron stars. They emit the regular pulses of radio waves, X-rays and gamma rays. So these three kind of the radiation are given by your neutron star and formed after supernova explosion of a massive star. So this one is formed after the supernova. Rotation period, this one is of millisecond to second, and extremely dense because the density is very high, and used as cosmic clock due to high rotational stability. First discovered in 1967, and pulsars show down over time due to energy loss because they are very massive, very magnetized. Regularly there is a loss of energy, so they can easily get down and end of their life. But the most important fact, pulsars are not black hole. You have to be focused on this point. Pulsars are not black holes. They are emitting the radiation but not the black holes. Next point, magnetars. When we talk about the magnetar, this is almost similar with neutron star. So this is also a very special type of neutron star. Also have a very strong magnetic field, 10 to power 14 to 15 Gauss, and the magnetic field is 1000 times stronger than pulsar. So both have the strongest magnetic field but 1000 times better than pulsar, and it causes, due to that magnetic effect, it causes gamma rays burst and X-rays flares. So there is a gamma rays burst and X-rays flares are there. When we talk about star quakes, occurs due to the magnetic stress, and it is present rarely. Only about 30 are known now. So they are very rare. But the most important one, the trap behind your questions category, magnetars are not a separate class from neutron star. I already said that this is almost similar to your pulsar. So this is also a type of neutron star. They are not separated. They are not a newly body, but only the magnetic field can be very high, 1000 times better than pulsar. This is known as your magnetars. Next body is your quasars. This one is very important one, and UPSC always interested to ask the question related with pulsar. So this is brightest object in the universe, and most of the time when you see the images of any galaxy, you find the center core of any galaxy is looking very bright, and this bright color is due to presence of pulsars and quasars. So quasars are mainly present in the center part of it. So it is brightest object in the universe. So they always look very bright. It is powered by supermassive black holes, galaxy centers. So they always present in galaxy centers. This one is a very important point. It emits the enormous energy from accretion disk because the lightning which is coming out from this center, this is due to the emission of energy. And this one visible from the billion of light year, because when someone can see the galaxy, so galaxy are present billion trillion years away from the earth, but we can see it due to its shining property. And older universe object used to study the early universe. This one is very important point, and it emit across radio to gamma spectrum. So radio waves and gamma spectrums are shows behind it. And what is the fact? Quasars are not a star. As I tell you, the bundle of a star or group of a star is known as galaxy, and the center part of galaxy is known as your quasar. This one is very shinier property. The next one is your nebula. We know it. In a basic manner, we know the nebula, and nebula is basically a dust bundle, or maybe we can say the group of some stars. So it is the cloud of gas and dust, and the birthplace of stars, stellar nurseries. And when the talk about the type of it, so there is a emission nebula is there, emission word is there, so it can glow due to the ionized gases. Also there is a reflection nebula, so it reflect the starlights, that's why the reflection word is used, but which can block the light rays. This one is called dark nebula, so it block the background light. And there is a planetary nebula is also there, where the outer layer of dying stars is present. So it is almost a dying star which is almost coming end of the life. And supernova remnants are also nebula. So nebula is a part of your supernova remnants also. If we take the example of it, there is a Orion nebula, we know it. This is the image of your Orion nebula. We see it in multiple time in our Instagram reels and many things. So this is called your Orion nebula, star forming regime. So this is the star forming region. Next one, when we talk about the life of a star, so you can see life of a star can be moved into many two stages. The first one is known as your formation, star formation. So it begins in nebula. You need to focus on these points very much, because this is very important. So it begins in the nebula. Always the formation of a star is a start from nebula. There is a gravity. The most important fact is gravity, gas, dust and collision. So there is a collision of gas and dust. So it forms first the protostar. What I mean by this protostar? The prototype of a star which can not exactly the star but look like a star, and then nuclear fusion is happening into star, and this is the main sequence of formation of a star. So now we are entering towards the main sequence where the fusion process is started. And you know that as a sun have the fusion process, two hydrogen molecule add and form helium. This is called fusion. Star remain stable. That is the sequence of your sun also. So sun is currently in this stage. They are adding hydrogen and forming the helium. And this is the reason behind formation of energy. Fusion process is there. And the duration depends on mass, because if mass is high, so duration is also very high. But when we talk about the next stage, so there is a death of a star when low, medium mass stars are there, and one is your massive star. So when there is a low medium like sun is considered as a medium star in space. So the main sequence, first it convert into red giant, then there is a conversion of planetary nebula where the outer layers are gone, and then the core become dark, and you can say the core become very cold. So this is called white dwarf. What we called it? White dwarf. The temperature goes down, and after the last, eventually it can completely cools down and black dwarf is made. So first the red giant, then planetary nebula. Nebula is a very shinier, but the core temperature is now reduced. Again the core temperature is more reduced, white nebula, white dwarf, and now when the temperature is fully gone, it is called as black dwarf that cannot be visible in space. When the massive stars are there, so this one have a bigger mass, so bigger mass, bigger energy, so the process is totally changed. You see, first is converted into supergiant, very massive body, then there is a core collapse, that is called supernova. This one is very important. So if someone asks you that what is supernova, so supernova is exactly the core collapse when a massive star is done its life. And also when we talk about remnant, what is rested after it? So there is a neutron star if mass is moderate. So mass is moderate, neutron star, and then if mass is very high, then it is finally converted into black hole. Actually this one is the result of main massive stars, that is called black hole. So this is known as your life. But how we observe these kind of the thing? So in space, lots of the things are going on. Galaxies are made, collapsing. Stars can be taking birth, can taking death. So the birth and death of stars are regularly going on, and also there is a destruction and formation of galaxies are also takes place. So how we can observe this? So we have a very important thing in space that is called James Webb Space Telescope. This is a very strategic, very important, because in current days we called this as a time machine, because it can see in space in million and trillion year ago, and that's why we can say it is a time machine. So what is going on in space that we are looking with James Webb Telescope? So let's talk about the basic feature of it. It is launched in 2021, operational since 2022. It takes 1 year to reach the important point. It is the joint mission of NASA, European Space Agency, and CSA. When we talk about the reason, it observes mainly the infrared radiation. And you know that infrared radiation is a minimum energy radiation present in space. So infrared radiation, primary mirror, this one is known as the primary mirror of it, made by gold. So 6.5 meter, it is the largest space telescope mirror, and it is positioned at L2 point, Lagrange point, L2 point. This one is placed, which is 1.5 million kilometer away from the Earth. And what are the key objective? So it study the early universe, because it is a time machine. So early universe study and the first galaxies. Also look at the star and planet formation, because regularly it can be happen in space. Exoplanet atmosphere, water vapor, CO2 and methane, and also uses sun shield, because we made this one with gold, and you know that gold is a very good thing which can maintain the sunlight shield for this James Webb Telescope. So for sun shield we are using the 5 layer to maintain very low temperature, so this one make itself very cold, and it is not replaceable. Only one time it can be sended, not replaceable, but a successor with different wavelength focus of Hubble, and this is the new name called Hubble. You know that in starting time we have also observatory in space that is called Hubble Telescope, but now we have the better one, James Webb. But we also talk about the Hubble one. So this is your Hubble Telescope. Also we use this for seeing the structure of galaxies and space. So Hubble Space Telescope, it is launched in 1990s, and it is the joint mission of NASA and European Space Agency, ESA. It has observed the ultraviolet radiation, visible light radiation, and near infrared. So you have to make a difference between James Webb and Hubble. James Webb is doing infrared radiation observation, and this one is for ultraviolet, visible, and near infrared. Also it is present in the low Earth orbit, like it cannot be present far away from Earth. So it is present in low Earth orbit, 400 to 600 kilometer height. And what is the key contributions? So it determine the rate of expansion of universe. This is very important one. As you know that multiple theories say that universe are expanding regularly, and this one is helping in the study of expansion of the universe. Also it provide you the evidence of dark energy in space. So this one is confirmed by Hubble. And high resolution images of galaxies, nebula, and black holes. What we have currently, this one is given by Hubble. It can be serviced because you can place it in low Earth orbit, so astronaut can go in space and just maintain it. So if any part of it can be damaged, we can easily replace it. So can be serviced by astronaut, and this cannot be happen with James Webb Space Telescope. And the famous concept, Hubble deep field, because it can see into the deep space. So this is the major difference between Hubble and James Webb, but both are very important one. Now we have XPoSat. It is called as X-ray polarimeter satellite, and this one is directly related with India. That's why it is very important for us. So when we talk about the XPoSat X-ray polarimeter, it is launched in January 2024. It is developed by ISRO. It is India's first dedicated X-ray polarimeter mission, and it can study the polarization of X-rays. The key instruments are there, POLIX and XSPECT. This is called as X-ray spectroscopy, and POLIX is known as measure X-ray polarization. This one is very important one. X-ray polarization is helping in the study of space, and it can observe the black holes, neutron star, and pulsars, and it help in understanding of geometry and the magnetic field of the cosmic sources. So this is also very important, and this is our Indian black hole, neutron star, and pulsar. We also have X-ray polarimeter. What is the measure thing? So it measures the direct and degree of X-ray polarization, provide information about the magnetic field and emission mechanics, how much radiation can be come out from a star, and important for the study of black hole, neutron star, supernova remnant, and complement imaging of the spectroscopy. It is the earlier missions lacked polarimeter, means before this we don't have the polarimeter with it, but due to technology challenges, but now we have. Next one is your black hole studies. It is only observational, that scientific nature cannot know about much thing about black hole, but we know it with the theories. And this one is a great image of black hole. So black hole are detected indirectly, not directly. So it cannot be directly observed. And the key observation method is X-ray emission from disk. So X-ray emission, motion of nearby star, gravitational wave, and gravitational lensing. Gravitational lensing is also a very major and key role play to find the structure of black hole. And when we talk about the X-ray polarimeter, so it reveals the spin of black hole. So we have a good study of black hole, and James Webb Telescope help in studying early black holes in young galaxies. And now we know about the structure of acceleration disk. Acceleration disk is mainly those disks which can revolve around a black hole. So these all things are studied by our astronomies. And this is the end of your topic, and now we have a PYQ. This can be asked in UPSC pre-2019. Recently, scientists observed the merger of giant black hole billions of light year away from the Earth. And what is the significance of this observation? So there is a merger of black hole. So what can be happen? So Higgs boson particle were detected? No, this is related with your plasma study. Gravitational waves were detected? No, there is a X-rays are present. Possibility to enter galactical space travel time through wormhole? Yes, this is okay, because you know that James Webb Telescope helping in seeing the entire space, deep space programs. So we can see, if you see the black hole, you can also observe the deep space structure. So this is your actual answer for it. So possibility to confirm the intergalactic space but can travel through the wormhole. It enables the scientists to understand the singularity. No, this cannot be related with it, only for the radiation. Again, we have some practice question for you related to this topic. So study the first one. This one is related to XPoSat, and consider the following statements. It is India's first dedicated mission to study X-ray polarization. It was launched by ISRO to study the exoplanet atmosphere. It carries instrument to study the black hole and neutron star. And what are the statements are correct one? Correct one. So it is India's first dedicated mission to study the X-ray polarization. This one is okay. It carries the instrument to study the black hole and neutron star. This one is also okay. But this one is launched by star, but not for the exoplanet. This is nothing relation with exoplanet. So your first statement is correct. Your third statement is correct. So your answer is first one. A option is correct. You also have a second question for your practice. And this is X-ray polarimeter is a particularly useful in astronomy. So X-ray polarimeter is useful in astronomy because it help in understanding. So it help in understanding. This is the question. Magnetic field geometry of celestial object. Yes, this is the correct statement. Emission mechanics of high energy radiation. Yes, this is also a correct statement. Chemical composition of planetary atmosphere. No, this is done by James Webb Telescope. This is done by James Webb Space Telescope. The chemical composition, internal environment and water vapors, carbon dioxide, this kind of the thing is done by your James Webb. So first and second is okay, not the third one. So correct one. So first and second. Clear? So this is your 2 practice question, and now I give you a third question for your practice, and you can just read it and see the correct answer, and you can just mention the answer in comment box after this video. So I hope this video is very helpful for you. So thank you very much.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.